this is 7.1, part 2. And our learning target for this part is we're going to use exponential growth models. So we're going to use them in different problems. Okay, so this example is a word problem. And you don't have to write this word problem out if you don't want to. You can if you want to look back at it. But it says in the last 12 years, an initial, and that means beginning, population of 38 buffalo in the state park grew about 7% per year. So this is an exponential growth, and the first thing they want us to do is write an equation to model the growth of the buffalo. Okay, we used this equation in Algebra 1 for exponential growth. Okay, the A is always your initial or beginning amount. The R is your interest rate in decimal form, so make sure to turn it in decimal form. If you get a crazy number for an answer, this is usually what happened. You forgot to put it in decimal form. Alright, so our initial amount of buffalo was 38. Our interest rate is 7%, which you move the decimal over 2 places. Remember, percentages out of 100. So if you divide this by 100, you would get 0.07, which is why we move it 2 places to the left. Okay, so 1 plus 0.07 raised to the t power. Let's clean that up just a little bit. 1.07. Okay, we have to add 1 to it to account for the original 38 buffalo, and then the 0.07 adds in the growth part of it. And remember, the growth factor has to be bigger than 1, so this would be our b value from our equation that we used yesterday. Okay, now let's use this equation to estimate how many buffalo are in the park after 5 years. Okay, so we're just going to plug in. I forgot to mention that t is time in years. Okay, so we'll plug in 5 for our t variable. And we just enter this in the calculator, and we get approximately 53 buffaloes. Alright, now another application of exponential growth is compound interest. When you put your money in the bank, you know it calculates interest on it, and the number of times that it calculates the interest, that's called compounding the interest. So we use this formula to calculate compound interest. Alright, so P is the money that we put in our bank account, and we call this principal. R, again, is our interest rate in decimal form. N is the number of compounding periods, the number of times in 1 year the bank calculates your interest. And T represents the number of years, the time in years. So let me talk about the number of compounding periods. If they use the word monthly, then that would be 12 because there's 12 months in a year. If they use the word quarterly, that would be 4 because they break the year into 4 quarters. If they use the word semi-annually, that would be 2 compounding periods. That means twice a year. If they use the word daily compounding, then you can just use 365. Okay, so we're going to look at one more example. It says you deposit $2,900 in an account that pays 3.5% interest. And this interest is compounded monthly. How much money will you have in your account after 1 year? Okay, so the principal would be $2,900. The interest rate in decimal form would be 0.035. Since it's compounded monthly, the compounding periods would be 12. We use this same 12 right here, and the time is 1 year. So you just enter this in your calculator, and your money would grow to $3,250. $3,002.55. So that's not too hard. All right, that's the end of part 2.